Bam! It's true. In my fourth video about conic sections, we're not going to just graph them. Sometimes we actually have to come up with their equations. So we're going to do 4 examples giving you information about these conic sections without telling you what the shape is, and see if we can come up with an equation. Now on my examples, I'm just going to have it set up like this, where I give you the words or description of what's going on, not an actual diagram. We're going to do that from the information given. Some of these questions in your textbook will give you a picture of a conic section and ask for the equation. Those are a little bit easier, and they'll relate to these anyway. I'm just going to make them a little bit harder by giving you just information without the picture. So maybe take a second and see if you can tell what this conic section is and what the equation is. Well, our focus points are, let's do those in, let's say, purple. Our focus points are at the values of 0, negative 2. So 0, negative 2, that's going to be a focus point. We have another one at 6, negative 2. So let's see here. 1, 2, 3, 4, 5, 6. Do a few more for good measure. 1, 2, 3, 4, 5, 6, negative 2. That's going to be another focus point. And our vertices, which I'll do in yellow like it's written, are at negative 2, negative 2. So left 2 and down 2. That's going to be a vertex. And my other one is at 8, negative 2. So this was 6, 7, 8. Now do you know what the shape is? Well, if you have 2 vertices and you have 2 focus points, then you're either looking at an ellipse or a hyperbola. So an ellipse is an oval, right? It's closed in. It's a closed graph, or closed graph. And a hyperbola is sort of like an ellipse blown out, where they open and the parabolas open up in the opposite directions. So the graph will always wrap around the focus points. Now I don't know, all of the information, but I know the graph is going to go through these vertices, and I know that it's going to wrap around the focus point. So it's something like that. I don't really know how tall this ellipse is going to be, but I do know a lot about it. I can look at this information. I'm sort of like giving you the graph as I go through the problem. The center of an ellipse is going to be in between either the focus points or the vertices. And this is kind of small, so I can just count it in. And so 1, 2, 3, 4, 5. So this right here is going to be the center of our ellipse. So we have a center of 3, negative 2. So what do we know? Well, now we know what the center is. And, to find the equation of ellipse, we have to know what direction it's going in. Well, the vertices and the focus points in an ellipse go along the major axis. And since these points, as you can see from my sketch from the information, it is geometry, right? It's analytical geometry. It's about shapes. Give yourself something to look at so you make sure that you're not trying to do it all in your head, and you don't get so confused so easily. This ellipse is going horizontal. So let me just put a reminder of that. It's going to be a horizontal ellipse. That means that A is going to be, we can write that actually. We have an equation. The standard form of an ellipse in a horizontal ellipse is x minus h squared plus y minus k squared equals 1. And because it is horizontal, I know that a squared is going to be underneath the x and b squared is going to be under the y. So from the information given, we've been able to find the center. We looked at the orientation of the vertices and the focus points and realized that it's a horizontal ellipse. So thus we have the standard form set up we're about to fill in. And we need to know what A is and what B is. Well, from center to vertex is A, and that's a length of 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so we have A is equal to 5. We have B, which is still unknown, and we've got C. Now, we gave, A goes from center to vertex, B goes from center to the end of the minor axis, because we're talking about an ellipse, and C goes from center to focus point. So my C value is equal to 3. Now, how am I supposed to use A and C to help me find out what B is equal to? Well, the formula of c squared equals a squared minus b squared. So we have 3 squared is equal to a squared, which is 5, and it will be 25 after we square it, minus b squared. So 9 equals 25 minus b squared. That's going to be, after you subtract both sides by 25, is negative 16 equals b squared. Whoops, negative b squared. And of course, we can just cancel out those negatives on each side of the equation by dividing both sides by negative 1. And b is equal to 4. I could fill that in, I guess, but we don't really care or need to know what b is, because to write the equation of this conic section, I need a squared and b squared, and I've already got b squared. It's equal to 16. So I plotted the points, I plotted the information so I could visually see what's going on. That allowed me to find the center and the direction. So I wrote down the standard form of that ellipse in the proper direction. We have a center of, again, 3 for the x and negative 2 for the y. There's a negative in the equation and a negative from the y that you're plugging in. A, as we identified, is 5, so a squared, we'll just write the 5 in there. So we're going to have 5 squared, because a is equal to 5, and b squared is equal to 16. So if I clean up this mess a little bit, we have our answer. It's x minus 3 squared plus y plus 2 squared equals 1. 5 squared is 25, and 16 from b squared, and bam! First example is done. Example number 2. Forgot to change the 2. I've purposely made this example sound or look very, very similar to the last one. Again, I'm asking for the equation of the conic section without giving you a graph, so you can just immediately tell what the shape is. And I'm using, again, the foci and the vertices as information for what we're going to try and find. So, is this an ellipse again? I'm given 2 foci and 2 vertices. If you have 2 foci and 2 vertices, again, you're looking at either an ellipse or a hyperbola. And a circle is a special type of ellipse, but the focus points are the same point as the center, because of the perfect symmetry of the circle. So, I don't know if this is an ellipse or a hyperbola. I wasn't told. So again, let's do the focus points in purple, negative 2, 2. And again, you might even notice these numbers sound very familiar. I did that on purpose. 8, negative 2. So 1, 2, 3, 4, 5, 6, 7, 8, negative 2. And my vertices, again I'll do this in yellow, 0, negative 2. And 6, negative 2. So, same type of information. Focus and vertices. And all the same numbers, but I've switched them. So my vertex, my vertices, or my 2 vertexes now, vertexes? My 2 vertices, are inside my focus points. I've just basically flip-flopped the values, or the coordinates. And that small twist means that we're now going to not find the equation of an ellipse, but the equation of a hyperbola. Remember, your graphs always go around or wrap around the focus point. So my graph is going to look something like this, and I'm not really graphing, I'm just trying to give a visual representation of what I'm trying to look for. So when my vertices are inside my focus points, then I'm looking at a hyperbola. If my vertices are outside my focus points, I've been given information about an ellipse. So now that we know, again, we still have a horizontal orientation, and just with a slight twist of those points, now I'm looking for the equation of a hyperbola as opposed to an ellipse. So now that I know the orientation of my hyperbola, I'm going to go ahead and write out the standard form, and then we'll just erase the values as we learn them and plug them in. So a horizontal hyperbola will have the positive fraction with the x in it, so it'll be x minus h squared over a squared minus y minus k squared over b squared equals 1. Now don't think I can just take my same old a and b values and plug them in and just call this a day and be done in 2 seconds, because you might get that wrong. So the information given tells us after the picture is drawn, again you can find the midpoint between either the vertices or the focus points, but our center is once again going to be 3, -2. So let's take out h and plug in 3. Take out the k and plug in -2. Alright, so my h and k are in there. I don't know what a and b are. Well, if my center is right here, from center to vertex is a. So a is going to be equal to 3. And from center to focus is c. So don't know what b is, but c is again equal to 5. Well, not again. It's the same number, but it stands for a different variable. I know what a is, so let's go ahead and erase that and put in 3. And let's find out what b is. Well, in a hyperbola, it's not c squared equals a squared minus b squared, but it becomes plus. So c squared is equal to a squared plus b squared. Well, c is equal to 5, so 5 squared. A is equal to 3, so 3 squared plus b squared, so 25. 9 for 3 squared equals b squared. And b squared is equal to 16. So my b value actually is the same thing, but my a value is not. So b squared is equal to 16. If we clean this up a little bit, we've got x minus 3 squared over 9 minus y plus 2 squared over 16. And we've got the equation of hyperbola. Next example. For our third example, we're told that the focus is -2, -1, and the directrix is y equals 5. What conic section is this? Well, I'm only given one focus point. Now, you could be only given one focus point and still be expected to find the equation of an ellipse or hyperbola. Certainly can finagle the numbers around and do that. But you're told that the directrix is equal to y equals 5. Well, there's only one conic section that has a directrix, and that is a parabola. So because of this, we know that we're trying to find the equation of a parabola. So let's get this information sketched down on a little xy axis. That'll help us, of course, understand what the shape is, what direction it's going in. So is it the x's need to be squared or the y's? Let's just see what happens. Our directrix is y equals 5, so I'm going to go up to y equals 5, make a dotted line. The equation of horizontal lines are, a horizontal line has an equation of, y equals a number, so y equals 5, there's our directrix. And our focus point is at -2, -1. So -2, -1. And there's my focus. So again, how do conic sections not deal with a focus, but how is the graph related to the focus? The graph is always going to wrap around the focus. And so I've got a directrix, I got a focus. So just from this alone, I now know that my parabola is going to be opening down. And the fact that the parabola is opening down means my final answer is going to be in the form of, let's see here, up or down means that the x's are squared, right? So it's going to be x minus h squared equals 4p times y minus k. And again, I know the graph is going down. Now a standard parabola that's vertical is going to open up, and by the way, a horizontal parabola that's standard direction is going to the right. Well, this is going down. So my 4p, when I'm done with my equation, that expression of 4p will need to be negative, again, because the graph opens down. That's why you really want to sketch this out to see what's going on. Well, what else do we know? vertex is in between the focus and the directrix in a parabola. And it's right in the center because remember the vertex is there somewhere in the middle, and then if you go a distance of p in one direction and a distance of p in the other, you go to the vertex and the directrix. Or this is upside down. We're going to go up to the directrix and down to the focus point. So somewhere in the middle of these values is our vertex. And this is a y value of 5. This is a y value of -1. The distance between -1 is -1 and 5 is equal to 6. Half of 6 is equal to 3. So I'm going to move up 3 spaces. Put a v there for vertex, and I basically just also figured out what the value of p is equal to. So my vertex is equal to, well, let's see, -2, +2. And my value of p, by finding the midpoint between the directrix and the focus point, I just discovered that it was equal to 3. So I'm actually pretty much done. My final answer is going to be x minus the x of the vertex, which is going to be -2. So x minus -2 squared equals -4 times the value of p, which is 3. Whoops. Times y minus the y of the vertex, which is equal to 2. So my final answer is going to be x plus 2 squared equals -12 times y minus 2. Bam! One last example. Get my remote though. Here we have our last example. Endpoints of points, the endpoints of the transverse axis are 3, 0 and 3, -8. The slope of the asymptotes are plus or minus 2/5. So again, I'm not giving you the drawing, just the information. And what is the conic section that we're describing here? What conic section has asymptotes? This right here is telling you that you're dealing with a hyperbola. So let's sketch the information, find as much as we can, get the standard form set up for whatever direction this thing's going to open up in, and do any kind of arithmetic we need to find the center or A or B. So the end points of the transverse axis, and by the way, a hyperbola is also the only conic section that has a transverse axis. Both of these names are specific to, or concepts are specific to that type of conic section. So we have a point at 3, 0, and another one at 3, -8. So 1, 2, 3, 4, 5, 6, 7, 8. Who do we appreciate? Okay, anyway. The endpoints of the transverse axis are, so the endpoints of the transverse axis, that's the line segment that connects the two vertices of a hyperbola. So that means that, well, these are my vertices. It also means that somewhere in the middle of this axis, we have the center. So this is 0, or y value of 0. This is a y value of -8. That's the distance of 8. Half of 8 is 4. So 1, 2, 3, 4. We've got the center. So what do we know? We know, well, we know the center. So the center is the point of 3, -4. We also know now that we have from center to vertex is always A, so A is equal to 4. We also know the direction. These hyperbolas are opening, this doesn't have to be pretty, so just something like that, okay? The hyperbolas are opening up and down. So our final answer is going to be in the format of, I guess we'll probably get it in here somewhere. So our final answer is going to be in the format of, let's see, vertical hyperbola. That means the positive fraction has to have the letter x or y that, relates to vertical movement, which is y. So we've got y minus k squared minus x minus h squared equals 1 over denominator of the positive fraction in a hyperbola is a. So that's going to be a squared and b squared. So just with this first line, I haven't even gotten to the asymptotes yet. just talking about the transverse axis, we've got the direction, and we've also got the center, which is at 3/4. It's going to be x minus the x of the center, which is 3, and y minus the y of the center, which is -4. So now all we have to know is a and b. Well, from center to vertex is a, so that's 1, 2, 3, 4 units. So we know that a is equal to 4. So the denominator for this positive fraction is going to be 4 squared. So just from the first sentence, in a quick little sketch, yours doesn't have to be all perfect like I'm trying to make mine, except for my really ugly hyperbolas. We've got everything we need except for b. So that means we need to draw our attention to this piece of information, which is that the slopes of the asymptotes is equal to plus or minus 2/5. Now when I was graphing hyperbolas, I kept stressing how if your hyperbolas are vertical, the slopes of the asymptotes are plus or minus a over b. And if your hyperbola is open and sideways, the slope of your asymptotes are plus or minus b over a. But with the graphing, it never really saw the importance of really having to know that. Well, now we're trying to come up with the equation. So when I see the slope of 2 over 5, if I don't know which of these numbers represents a or b, and we are talking about a fraction, so it could be very well be in reduced form, that could be an issue. So if we don't remember that for vertical asymptotes, slope is plus or minus a over b in reduced form, again, sketching the information given will also hopefully help you remember, remind you of that. From center, when we graphed hyperbolas, it was always about graphing the center and then doing some kind of box thing. I don't really know what the box shape is yet because I don't know what b is, but we would draw the asymptotes through that box, and we talked about how slope was from center to the corner. So with this little sketch, c, slope is rise over 1. When we go up and hit the vertex, that's a. So, as we have already identified. So this slope, which is equal to 2/5, is telling us our final ratio of a over b. So we're going to do a little bit of work to find out what b is here, okay? So we've got 2/5, the actual slope of the asymptotes, positive, negative, equals, what is our actual measurement for a? Our actual measurement is equal to 4, and now we're trying to find out what b is. Now 4 is twice as big as 2, and so b is going to be 10, but just in case you can't just look at it, you're going to cross multiply this and get 2b is equal to 20, and when you divide by 2, you're going to get b is equal to 10. So, our last denominator that we didn't know, which was b squared, is equal to 10 squared. And our final answer, all cleaned up, is going to be y plus 4 squared minus x minus 3 squared equals 1. This denominator is going to be 16. This denominator is going to be 100. I'm Mr. True. Go do your homework.